always does this. Okay, there it is. Okay.
Okay, yeah, perfect.
So there's a house up here, and there's 3 sides, and to this thing. So I'm going to use X for the width here and Y for the height. It's kind of standard for us here. And the next step here is to just consider what it's giving. We're trying to maximize the area. And area equals X times Y. And then our constraint, though, is that we only have $240 for the project. The east and west sides are $5, and the southern boundary is $10. So the cost along one of these sides vertically is 5 times Y plus 5 times Y plus 10 times X. And that's 240. That's all that's available for that. So this is 10Y plus 10X equals 240. We can divide everything by 10, so X plus Y equals 24. And we solve for Y equals 24 minus X. We're doing that because we want to put that back into this area equation.
Wait, where'd you divided? Okay, so you divide
everything by 10.
10. Okay, and you got 24.
Yeah, and then you just solve for Y. It's 24 minus X. So our area is X times 24 minus X, which is 24X minus X squared. And we have to take a derivative. The derivative is 24 minus 2X. Set that equal to 0. So X equals 12.
Okay, yeah, that makes sense. I had a different tutor explain it to me earlier today. That's why I wanted to go over it again. She just really confused me. So that makes sense.
Okay, so the problem you're going to get in the exam will be the exact same, except the numbers will be slightly different. And you know that that's the only change here is where those numbers fit in, and you'll get something very similar. So the Y value is 24 minus X. So that's 24 minus 12. And then the area you get from X times Y. So that's how those numbers come together. All right, let's see here. So that was 24. Going to get 25 next, if that's okay.
Yep.
If you ever need a time other than the ones that are shown, just send me a text, and I'll add one if you need it.
Oh, really?
I just sort of set my preferred schedule, but I'm usually available for regular customers. So, okay, so we got a triangle here. I'm going to redraw it because it's got a lot of extra stuff in here. This is X, this is Y, and the left border costs $4, and the lower border costs $1. And we want to maximize area again. We want to maximize area. So the area is 1/2 base times height. The base is X, and the height is Y. And you have $80 to spend on as much as you can. So along the left here, it's 4Y plus 1X equals 80. And you generally always solve for Y. So 4Y equals 80 minus X, and Y equals, you're dividing everything by 4 here. I'm gonna go, I guess, what 20 minus 1/4 X. We'll just do it that way. So now this gets substituted in here. So A equals 1/2 X, 20 minus 1/4 X.
Equals 1/2.
And then I'm just going to distribute this in. So it's 1/2 times 20 is 10, times X is 10X. 1/2 times 1/4 is 1/8 X squared. And this is where you take a derivative.
Okay.
The derivative is power rule. It's 10 minus, bring the 2 down, 1/4. 2/8 is 1/4 X. Set that equal to 0. If you move the 1/4 X over, you get 10 equals 1/4 X. Multiply both sides by 4, and you get 40 equals X. Okay, so X is the bottom border. If you look at the answer here, that's what we called X. Y is 20 minus 1/4 X, or so that's really your X there. So that's 20 minus 10, which is 10. That's your Y. And then your area is 1/2 X times Y, 1/2 40 times 10, which is 200. All right, so 24, 25, I saw 27.
Yeah, wait 1 second. I'm still writing.
Sure.
20 minus 10, so y is 10. Okay, yeah, we can go to 27. So for these ones, like as we start to get into these, I'm not as familiar, so I kind of need to go like slower, and I need some steps.
For starting at 27?
Yeah.
Okay. All right, so starting with 27, the revenue is price times quantity, and P is your variable, so that stays. Q comes from right here. Minus 10P plus 4660. Okay, so if we multiply, that's minus 10P squared plus 4660P. And that's your revenue. That's your revenue as a function of P. To find the largest or the max revenue, you have to take a derivative.
Okay.
So R prime of P equals minus 20P plus 4660. And then you set that equal to 0. Okay, so to solve this for P, I'm going to just move this over to the other side. 4660 equals 20P. Divide by 20, divide by 20. So P ends up equaling 233.
Okay. And oh, that's not okay. So it's positive. Sorry. Yeah.
Okay.
So,
Now to find the revenue, you have to go back to this line up here. Your revenue function is given as minus 10P squared plus 4660P. And you have to find the revenue at price 233. So you put that in for P. And this is where you got your calculator. You just plug that in and you get 542,890.
okay. So you create your revenue equation, and then you take the derivative.
Set it equal to 0. Yep.
0, and then plug that number into the derivative revenue equation.
Not into the derivative, and back into the regular revenue.
Into the original.
Yes.
Wait, but oh, okay.
This is the equation we plugged it back into. That's the revenue equation. That's this one line here.
Oh, okay.
All right, looks like 32 is next. This one's completely unrelated. So are there any other max revenues? Like 37 might be better to do next.
Yeah, we can do that next.
Or 36.
Either one, honestly, doesn't matter.
Okay, let's do 36.
Okay.
Okay, so this one asks for the price elasticity of demand. And that's a formula. That's something that you have to have down. Price elasticity of demand, that's E equals minus P over Q times dq dp. So you have your price. Your price is 32. That's given. Your Q is a function. It's 912 minus 19p.
Okay.
So that's 912 minus 19 times 32. So let's just get that number right now. I'm sure that's how you would do it on the exam. You would grab your calculator and calculate this.
912 minus 912 minus 19 times 32. So 304.
Okay, so that's the next two parts. Now dq dp is the derivative of this thing up here. It's minus 19, just the derivative of this function up here. That's power rule.
That's the derivative of Q.
Yes.
Okay, yeah. Okay.
So now we're going to write the elasticity formula again, minus P over Q times dq dp, and we're just substituting in the numbers we just found. The price is 32, so it's negative 32. Your Q is 304 times minus 19. Minus 32 times minus 19 over 304. And that equals 2. So that's what goes in that first box, and it also goes in this next box. These are always the same.
Okay.
This is where I'm really not sure what to tell you, but here.
Up. Because it's positive.
The thing is, I've done these problems so long. This number is always positive.
Oh, okay.
But here's what I would tell you. Whatever the answer is here, it's always the same for this question.
Okay.
Like whatever you get on your exam, it's gonna be this. Okay, now next one is max revenue. Revenue is price times quantity. Your price is your variable. Your quantity is 912 minus 19p. That's your Q. So when you distribute that P, that's 912p minus 19p squared.
Okay.
Now we have to take a derivative. So the derivative with respect to P, it's power rule. So it's 912 minus 38p.
Okay.
And then you set that equal to 0. So you move the 38p to the other side. And that ends up equaling 24.
Okay.
So it's just like the previous problem. Price times quantity. You write that. Distribute in. Take a derivative. Solve it for P after setting it equal to 0. That's the price. That's the answer to part C.
Okay. And then
Find the maximum revenue. You have to use the revenue function, which is this line down here. Revenue P equals 912p minus 19p squared. R of 24 equals 912 times 24 minus 19 times 24 squared. So let's get that number.
Okay. 912 times 24. Is it 10,944?
912 times P minus, I got the wrong numbers in here. Yeah, 10,944.
Okay. We can move on. Wait, actually, let me just plug these in to make sure they're right. Okay, yeah, except the demand is going down. That's weird.
Yep.
There.
Okay. Now 37 is what would be next on our list here. It's a more complicated version of what we just did. I don't recommend we do it. If there was ever one that wouldn't be on there, it's probably this one. But I mean, of course, I say that, then maybe it's not on there. It is the exact same steps. You know, it's multiply, take the derivative, so on and so on. But I'll leave it up to you. We can go to 38. It's kind of like the one we just did.
Let's see. I'm just gonna say let's do it because my friend said this question is on the test.
Okay. All right. All right. So the first thing they want is the price for elasticity formula. That formula here for part A. I have to come down here and do part A. E equals, I'm using lowercase e, but it's uppercase up here, minus P over Q times dQ dP. So the price is the variable. They don't give you the price here. They give you a price down here in part B, but part A, there's no price. So you keep that. Q, this is Q. Your Q is right here.
Mm-hmm.
And then you need a derivative. So you have P. Q is minus 2P squared plus 33P. And then you have to take a derivative of that. The derivative of that is minus 4P plus 33.
Okay.
So now we're just going to fit that into this formula. So we have minus P, because that's what it is. Q, our Q is minus 2P squared plus 33P times minus 4P plus 33. And I don't know if this was with you, but I remember this problem. You have to simplify all this. Like, it doesn't just take this, unfortunately. Like, you have to do some things here, some algebra, if you will. And this is where it gets a little like unclear, because this is not a calculus thing. It's not a business calculus thing. It's just purely like manipulation of equations. What can you factor out of the bottom? You can factor out a P from both, but you can actually factor out a minus P, and that works really well with what's up top there, because there's already a minus P factored out. So we have minus P, and this becomes 2P minus 33. So if you're not sure, if you don't like anything in the bottom here, you can always work this backwards, where you multiply in, and do you get back to this line when you multiply in? And you do. I mean, you get minus 2P squared plus 33P. You're great. Now these things cancel, and you end up getting minus 4P plus 33 over 2P minus 33.
Wait, what cancels? Oh, the two P's cancel?
This P cancels here and here.
Okay. So it becomes minus 4P plus 33 over 2P.
Yeah. Now, my recommendation, if I were taking this test and I got this question, I was a student again, I would almost want to, I might go back and use this formula for some of the other stuff, but because what if I made a mistake here? Or you could check this part. I think you can check this part before you submit the other parts. I don't remember. I mean, I don't know what your instructor is, but I would check this, check that this is right. If it is right, we'll use it for part B. If it's wrong, well, then we got to decide what to do. But it gives you some information to work off of.
I don't think I could check it on the test, but definitely right now I can.
Okay.
Yeah, that's right.
Okay, so part B is it gives you a price. It tells you that price is 10, And you're going to put that price into this formula. Minus 4 times 10 plus 33 over 2 times 10 minus 33. It does say to round your answers, so you definitely need your calculator. All of this is in parentheses on the top and the bottom. And I get 0.54 for that.
Yeah, I got that too.
Now, since this is less than 1, it's on this side. The other answer was more than 1. I think you said the previous problem, the what did you say for the previous problem when we number 36, what the demand is going? You said it's going up.
Oh, it's going down.
The 36 was going down.
Yeah.
Yeah. So here, because this number is less than 1, I believe that the answer will be that it's going up, and that's also part of part B. So this number is 0.54. This number is also 0.54. These always match. And then because it's less than 1, that's why it's going up.
Okay. No, it's going down. But everything else is right.
I would encourage you to check in with your instructor about that before. I'm sure there's a very clear understanding of why that is. I don't have it.
Okay.
Okay, so revenue is price times quantity. Price times quantity. P is the variable. Q is what we got from the first part of the question. Q is minus 2p squared plus 33p. And it's minus 2p cubed plus 33p squared. So this is the first part. Then you have to take a derivative. You have to take a derivative with respect to p. R prime of p equals minus 6p squared plus 6p. And you set this equal to 0. Now this is the first time you have to factor out. You have to factor a
Is it not minus 2p3 plus 33p squared?
yeah, actually that is wrong. That is wrong. So that makes that 66p. Okay. So you're going to factor out a minus 6p. And that leaves you with p minus 11 inside here. So there's actually two places where this is 0. Minus 6p equals 0 and p minus 11 equals 0. So the one answer is p equals 0. The other is p equals 11.
Okay.
But if you go back to the very beginning of the problem, it says 9 less than or equal to p less than or equal to 15. This is the only one that's good. This one's it's outside the domain.
Okay, so it would be p equals 11 because of that.
Yeah.
And that is
That's part C, first answer.
okay. And then the revenue.
So the revenue, we need the revenue function. So our revenue function, it's this line up here. So we've got that, and we just need to write it again. So revenue function is minus 2p cubed plus 33p squared. So we want to find the revenue at price equal to 11. Minus 2 times 11 cubed plus 33 times 11 squared. And we should get that number. Let me get that number here. 1331.
Okay. 1331. Okay, yeah, all that's right. So.
All right. Do you want us to do 38?
Is it like the same thing?
Yes.
Okay, well, I'll just try to figure that out on my own.
Okay. All right. 38. Okay, so we've skipped a number here, a number of these in the middle. We skipped these kind of related rate questions like 34, 32 and 34 and 33. These are all related rate problems. These would be the next ones to do. So
Okay, yeah.
33, I guess, next.
Yeah.
Okay, the radius of a circular puddle is growing at a rate of 5 centimeters per second. That is your R prime. Your R prime equals 5. It says radius, it's growing. That means it's positive. That's the number there. How fast is its area growing? That's A prime. A prime. So we need the formula for area. Area of a circle is pi r squared. A prime equals 2 pi r prime. So if that's not clear, this is like implicit differentiation. It's like the derivative of y is y prime, the derivative of a is a prime, the derivative of r is 2 pi r. That's power rule, but there's always this r prime that goes with it. Some instructors write like dr dt or something like that. I generally just use these primes because they're shorter and this means the same thing.
Oh, okay. So that's what that means. Okay.
Yeah, and these primes are easier to write. This has got more strokes and kind of a minimalist, so I don't
Okay.
do a lot extra if I don't have to. We're solving for a prime. Okay, so we've already got a prime there. Do we know the radius? Yes, the radius is 10. It's given. It's given in the question. Radius equals 10. Do we know our prime? Yes, it's 5. So this is 100 pi. It does say to round to the nearest integer, so it's 100 times pi. So that's 314 on that.
Okay. So 314.
Yep.
Okay, so all we did was just take r prime, take the area formula, get the derivative of it, plug in r prime, and got that.
And the radius, yeah. Yep.
Okay. Okay.
All right, so in part B, oh, and I mean, the only thing that's going to change are these red numbers. Like if you had this formula written down, you're going to just plug in 10 and 5 and be done.
Okay.
And that's all. How fast is the area growing? So that's part B is also asking for A prime. So you might think, well, what's different about it? Well, there's an intermediate step. It says when the area equals 36. So they're telling you the area equals 36. 36 is equal to pi r squared because that's the area formula. You can solve this. You can solve for r. Okay, so you divide both sides by pi. Okay, and then you take a square root of both sides, and that's your r.
Wait, so they want you to plug in, so they're giving you the area as 36 and they want you to plug in.
They want you to find r to use it in this formula for a prime.
Okay, so 36 equals pi r squared, and then 5 by 36. Okay.
That's your radius. Okay. The a prime formula is this, the square root of 36 over pi, and your r prime is still 5 because that's given at the beginning of the problem, and it applies to both parts A and B.
Wait, I think you froze for a second. Let me just catch up.
Sure.
Two pi 36 over pi and then times 5. Okay, I'm ready.
Well, that's it. You just put the numbers in and you get out 106.
Okay. And that's part B.
That's part B. Yep.
Okay.
All right, 33. Part 33 only has one part to it. All right. A rather flimsy spherical balloon. Okay, so the radius is 4 centimeters. That's given there. And then it says that its volume, this is volume right here, cubic centimeters per second, V prime is 16. So one way I know it's V prime is I look at the units. If it's something per time, then it's a derivative, almost always. So see how it's just centimeters up here? I know that's not a derivative.
Okay.
So the volume is given. It's 4/3 pi r cubed, and they want how fast is the radius growing? They want r prime. That's what they're trying to figure out. And the way you do this again is you just take a derivative. Derivative of v is v prime. Oh, is my audio okay? Because I had someone tell me earlier it wasn't so good.
No, it's good.
Great. Okay. This is power rule. 3, bring the 3 down. So 3 times 4/3. 3 times 4/3 pi r squared r prime.
Okay, where'd you get the, so I know you said V prime is 16, right?
Well, we're not putting numbers in yet. I mean,
Okay.
that's the next step, but yeah.
Okay.
Are you okay with this derivative?
Yeah. Yeah.
Okay, so I'm just going to briefly just cancel this as 4 pi r squared r prime, v prime. V prime is 16. The radius is 4, and r prime is what we're solving for.
Radius is 4. Okay. Okay. So do we just multiply like 4 pi times 4 squared and then move it over to the other side?
Yeah, you just divide. I mean, you can multiply this out on the right, like it ends up being 64 pi r prime. You can divide both sides by 64 pi. And so r prime equals 16 over 64 pi.
So, okay. So is that the answer?
After you put it into the calculator.
16 divided by 64 pi.
And just make sure that bottom is in parentheses. It's so easy not to do that, and then you get an answer that's not even close to correct. What does it say to round this to? 2 decimal places?
Yeah.
0.08. The other thing you might do is write down the answers to some of these that you did, for practice. Like your answer to this question on the real exam shouldn't be like 1.10, 1.15. It should be around this 0.08, 0.07. It won't be like that much different.
Okay. All right, we can move on.
All right, so 34 is, I think it was a ladder problem. Yeah.
34, yeah. So my teacher did this in class and I was able to like kind of follow her work and I solved it.
Okay.
But let me just see if I can find my work and I'll ask you what my question was about it. So she basically did like Pythagorean theorem kind of like.
Yep.
So we had like h squared plus b squared equals 30 squared, and then made like a different equation where 2h,
Take the derivative. Yeah.
yeah, and then uh and then like found h through the Pythagorean theorem,
Yes.
and then plugged it back in. I think we might as well just do it because I need to know this. I need to know the proper steps. I kind of just copied my notes.
Okay. Do you generally draw your triangle this way, or do you want me to use the one that's this way? Which way do you
You
draw
can use
things in?
the other one.
The one on the left?
Yeah.
Okay. All right. So I'm going to do this different because I'm going to use X, Y, and L because L is the length of the ladder.
Okay.
And X is horizontal, Y is vertical. We've done that in all the problems, so that's very consistent.
Okay.
So the Pythagorean theorem says that X squared plus Y squared equals L squared. And your L is 30, and the base of the ladder is 18. So that's so we need to solve that for Y squared. So 18 squared is 324. 30 squared is 900. And square root of 900 minus 324 is 24. So y ends up being 24 here when you solve for that. So I'm going to put those numbers on the inside here. That's 18, that's 30, and that's 24. Now this is important. It says that it's being pulled away from the wall at a rate of 10 feet per second. That means that this direction, which is x prime, is equal to 10 because it's a rate.
Okay.
You follow that? So if the ladder is being pulled out, then it's going down. So y prime, which we don't know, that's what we're trying to find. It's going down. You see that? Does that make sense visually? Yeah. Okay. All right. So this is where I think there could be some confusion because like you understand everything I hear. You have to take a derivative of this equation, but you do it implicitly. So do you know what I mean by that implicitly here?
Not really.
So it's 2x, but then it's x prime plus 2y, y prime equals 2l, l prime. So your instructor would have had like 2a, a prime, 2h, h prime, 2d, d prime maybe. I don't really know.
Yeah.
Something like that. Okay. This is really important. L prime is equal to 0 because the ladder isn't, that part of the ladder isn't moving.
Okay.
So like that means this whole right side is 0.
Yeah.
Okay. And then you're going to solve this equation on the left here. You're going to solve for y prime. So we're going to move this to the other side. 2y, y prime equals minus 2x, x prime. Divide both sides by 2y. Y prime equals, these 2's cancel, minus x, x prime over y.
Okay.
So now we have all of those values from the table or from the figure above. X is 18, x prime is 10, y is 24. And I guess that equals negative 7.5. Now, this is where you need to remember that because it's sliding, it's already saying sliding down. The negative is not included in the answer.
Yes. Okay.
It's one of those really things that, I mean, you get the whole problem wrong because of a sign, and I would hate for that to happen. So keep that in mind. Okay, so here are some questions we have not done. 31. 35, and I guess that's it, and 38. So between 31 and 35, do you have a preference for us?
Yeah, I mean, 31 was just like kind of like that part B. I just wanted like an explanation basically because they gave me the answer. I just don't really know how I got it, but 35 is probably more important.
Okay. Do you see in 31 that it's the same answer for both?
Yeah.
Okay, it will be on the other one. It's where the graph changes concavity, if that
Okay.
wasn't explained, but the answer is the same for both. It'll be that way on your exam. Okay.
Okay.
So 35 here. All right, so the average cost is this function. This is the average cost function right here. It says that it's got this bar on top. That is the average cost function. Okay, they tell you that weekly production is currently 3,000 players. So that's X. X is 3,000. And X prime is 200.
Okay.
So I mean, this is where most certain we're taking a derivative. Weekly production. So let me read the question. What is happening to the average cost? The average cost is blank at a rate of, okay. So we have to take the derivative of C bar. So it's C bar prime of X, meaning just the derivative of this thing. So that's power rule negative 160,000 X to the minus 2, because you always subtract 1.
Yeah.
The derivative of a constant is 0 plus 0.002 no x. But because you have a rate here, you have to multiply everything by x prime because of this thing right here. Normally x prime is 1, but it's not in this problem.
Okay, so you're multiplying by x prime.
Yes, the whole thing though, not like just one of them, the whole thing.
Okay.
Okay, so now you're gonna do C bar of 3,000 minus 160,000, and then the 3,000 is really on the bottom.
Why is
What?
that? Oh, yeah,
Negative exponent, yeah. All right, so this is a calculator thing, obviously. Minus 160, 123 over 3,000 squared plus 0. All of that. So I get negative 3.52. So the average cost is decreasing. We definitely want to check this at a rate of 3.52. So since it's negative, that's why it's decreasing, but you don't put that number, you don't put the negative in this part.
Okay. 3.52. Yeah, that's right. Sounds good.
Did you say that was right?
Yeah.
Okay. Well, we got through everything.
Okay, cool.
And I will send this out to you within the next 30 minutes or less. If I don't, you can always text me, but I would encourage you to rewatch the lesson if you need to, or at least have the PDFs, and because the only thing that will change are the numbers. So if you know where the numbers go, you can absolutely pass this with a great grade.
Okay. Thank you so much, Matthew.
You're welcome. I'll see you next time. Thanks again for scheduling.
Yeah, for sure. Yeah.
Bye.